Hello everyone, welcome to MecH'y's Classroom. MecH'y's Classroom brings you the Thermodynamic Revision Series for SSC JE Prelims 2019. The weightage of thermodynamics in SSC JE Prelims is around 12 to 18 marks. The syllabus is Basic Concepts of Thermodynamics and Zeroth Law, Heat and Work, First Law of Thermodynamics, Second Law of Thermodynamics, Entropy, Properties of pure substances, and Availability. In this revision series, I am going to discuss the previous year questions and its concepts. First, let us take the first topic, that is basic concepts of thermodynamics. It has around 6 main topics like what is system, what are properties, what are gas laws, and what is zeroth law, what is thermodynamic equilibrium, and in the end we will discuss about specific heat at constant volume and constant pressure. Moving to the first question. Hot coffee stored in a well-insulated thermos flask is an example of isolated system, closed system, open system, and non-flow adiabatic system. First, let's discuss what is system. In thermodynamics, we identify the subject of analysis by the term thermodynamic system, or simply you can say anything which is under consideration. Like that, we have around 4 systems: isolated system, closed system, open system, and adiabatic system. For this question, the answer is isolated system. What is isolated system? Isolated system is a system in which there is no energy or mass that crosses the boundary. We will discuss the different types of systems. First one is open system. In open system, mass transfer as well as energy transfer can take place across the boundary. Next, closed system. Closed system is in which only energy transfer can take place. The energy can be heat as well as work, but there is no mass transfer involved in a closed system. Moving to the isolated system. In isolated system, neither mass nor energy crosses the boundary of the system. Adiabatic system. In adiabatic system, mass can cross the boundary, but heat cannot cross the boundary. Work interaction can be done. For example, turbine. In turbine, mass is flowing, but there is no heat interaction with the surroundings. In the end, we are getting the work output. That is work interaction with the surroundings. Moving to the second question. Mixture of ice and water form a closed system, open system, isolated system, heterogeneous system. What is heterogeneous system? It is a combination of two or more homogeneous bodies. Here, ice and water form homogeneous bodies. The correct option is option D. Moving to the third question. A control volume is in flow system, mass is flowing through the control surface and work interaction and heat interactions are happening. From the figure you can see a dotted white line is control surface. Anything which is confined within that wall is control volume. So option is option D is the correct answer. A fixed region in space where mass, heat, work can cross the boundary of that region. Moving to the next concept. Which of the following is an extensive property? Temperature, pressure, density, enthalpy. What is extensive property? Extensive properties are those whose value depends on mass. For example, enthalpy, kinetic energy, entropy. The formula for kinetic energy is half mv square. The kinetic energy depends on mass and velocity. So it is an extensive property. What is intensive property? Intensive properties are those whose value is independent of mass. Example are pressure, temperature, thermal conductivity, density, specific enthalpy, viscosity. For question number 4, answer is option D, extensive properties, enthalpy. Moving to the next question. In case of Boyle's law, if pressure increases by 1%, the percentage decrease in volume. The options are 1 by 101 percentage, 100 by 101 percentage, 1 by 100 percentage, and 0 percentage. First, let us discuss what is Boyle's law. Boyle's law states that absolute pressure of ideal gas varies inversely with volume when temperature is constant. If I apply this Boyle's statement to two states, then it becomes P1 V1 equal to P2 V2. In the question it is given that if pressure increases by 1%, that is if P2 is 1.01 of P1, substituting in the equation we get P1 V1 equal to 1.01 P1 V2. Rearranging the equation we get V2 as V1 by 1.01, which is equal to 100 by 101 V1. And the question asked is the percentage decrease in volume. The formula for that is V1 minus V2 by V1. After substituting, we get answer as option B. Now, let us discuss some more gas laws. They are Charles' law, which states that the volume of given mass of ideal gas is directly proportional to its absolute temperature when pressure is constant. The formula is V proportional to T. Next, Gay-Lussac's law. Here, pressure is directly proportional to absolute temperature when volume is held constant. Next, Joule's law. The change in internal energy of a perfect gas is directly proportional to change in temperature. Moving to the next question. According to which law, all perfect gases change in volume by 1 by 273.1/5 of their original volume at 0 degrees Celsius for every 1 degree Celsius change in temperature when pressure remains constant. Here it is given pressure remains constant, which is the definition of Charles' law. This statement is another definition of Charles' law. So option B is correct. Moving to the next question. Zeroth law of thermodynamics defines internal energy, enthalpy, temperature, pressure. We all know that the basis for temperature measurement is zeroth law of thermodynamics. So option C is correct answer. The definitions of zeroth law of thermodynamics are when two systems are in thermal equilibrium with the third system, they are also in thermal equilibrium with each other. Or if A is in thermal equilibrium with B and if B is in thermal equilibrium with C, then A is also in thermal equilibrium with C. Now moving to the next question. The boiling and freezing points for water are marked on temperature scale P as 130 degree P and minus 20 degree P respectively. What will be the reading on this scale corresponding to 60 degrees Celsius on Celsius scale? Correct option is A. We will see how to solve. Consider P or any scale. It is given that the boiling point on P scale is 130 degree P and ice point is minus 20 degree P. And on Celsius scale we know that boiling point is 100 degrees Celsius and ice point is 0 degrees Celsius. And the question asked is what is the temperature on P scale corresponding to 60 degrees Celsius on Celsius scale? And we know this formula. When you substitute corresponding values in the given formula, we get answer as 70 degree P. Now let's discuss what is specific heat. Specific heat of a substance can be defined as amount of heat required to raise the temperature of its unit mass through 1 degree Celsius. All the liquids and solids have one specific heat, but a gas can have any number of specific heats lying between 0 to infinity depending on the conditions. We have two types of specific heats for a gas, that is specific heat at constant volume, which is defined as change in internal energy to the change in temperature. The supplied heat is utilized to increase the internal energy and there is no work done by the system as PD work is 0. Next, we have specific heat at constant pressure, which is defined as change in enthalpy to the change in temperature. The supplied heat is utilized to increase the temperature of the gas and there is also PdV work done by the system. Therefore, Cp is greater than Cv. These are some important facts and formulas you need to remember which may appear in exam. That is Cp minus Cv is equal to R, Cp by Cv is equal to gamma, Cv is equal to R gamma minus 1, Cp equal to gamma R by gamma R minus 1. Here gamma is specific heat ratio. For ideal gases, Cp, Cv, gamma do not change with change in temperature. But for real gases, if temperature increases, Cp and Cv also increases, but gamma decreases with change in temperature. Moving to the next question. Which of the following is false? Options are Cp is always greater than Cv for gases. Second option, gamma is always greater than unity. For ideal gases, gamma increases with temperature. Option D, gas constant is equal to universal gas constant divided by molecular weight. So our correct answer is option C. We have just seen Cp is always greater than Cv. Option B, gamma always greater than unity. We know that Cp minus Cv is equal to R. If I substitute and get the equation for gamma, we get it as gamma equal to 1 plus R by Cv. So gamma is always greater than unity. And option D is gas constant is equal to universal gas constant divided by molecular weight, which is the formula. So option C is correct answer. That's all for today. See you in next videos. Thank you.